are ready for our next speaker, and she is an academy instructor of the Nasser Vocational Training Center here in Bahrain. She obtained her Master's of Information Technology from the Technological University of the Philippines and her PhD in Information Technology from Hamad University. So to talk to us today about something that academics would really be interested about, presenting a model to detect the student's type of understanding based on emotion recognition. Wow, it's very interesting. So it's my pleasure to introduce to everyone Dr. Raiza Borreo. Hello, Ms. Raiza. Good morning.
Good morning, Dr. Levardo. Good morning, ladies and gentlemen. And thank
Glad
you,
to have
Mr.
you.
Levardo, for a very good introduction. I never
Wonderful.
expected that, actually.
Okay,
Okay,
ma'am. So yeah, the floor is yours. Take it away.
thank you so much. So once again, I am Dr. Raiza Borreo. I am currently working for Nasser Vocational Training Center, and we're catering grade 10 students. So it came to my curiosity, how am I able to connect with my students, especially that these are Arabs, and my nature of work is exposed to Filipinos for the past 10 years. So I was trying to connect this lines between them and the teachers. So I came up to this idea, why not propose or create a research study regarding the method of understanding, or the way the students understand the lessons. So my research is actually entitled as a model to detect
Grabe ka ba ko? Grabe, nangangatal yung kamay ko kaya hindi ako
the students'
maka, ng
understanding
ayos. Nangangatal.
based on emotion recognition. Okay, so here is how the history of emotion recognition started. So it's in 1872 of book authored by Charles Darwin, which is The Expression of the Emotions in Man and Animals, where he iterated that the expressions of emotions of man is very universal, which means if you're fearing, you can actually show that on your face emotions. Okay? When you are happy, your emotions are actually surprise or anything else, it can actually reflect on your face. Okay, now many years later, okay, this psychologist named Paul Ekman, okay, pioneered a research connected to the theory of Charles Darwin, where emotions are universal. So he called this theory then as theory of emotions. So by then, Paul Ekman, together with his team, collected several photos, and they labeled it with different or various emotion categories, such as anger, happiness, surprise, and fear. Okay, there's also neutral, and I'm gonna discuss this furthermore later on. So he also found out, okay, together with his friend Wallace Friesen, that the emotions of humans are really universal, just like Charles Darwin's theory before. So now let's connect these emotions to a typical classroom. So a classroom is an avenue for learning, all right? This is where the teacher and the students meet. The teacher delivers his lesson, the students will understand, supposedly. However, most of the time, and I also experienced the same thing, my students wouldn't be able to grasp what I am talking about, even though I tried my best. I used other languages or forms of discussion. There are also some moments that they cannot connect to what I am saying, all right? Especially my students are in grade 10. So their maturity in the side of learning is not yet full grown, or there's still a room for improvement. So teachers usually prepare the lesson, okay, to the best that they could, okay? Usually it's a visual presentation, and the students are expected to listen, all right? But no matter how the teachers try their best to connect with their students, there are still lapses, all right? We don't know what are these lapses are coming from. It could be a problem on the teaching strategy of the teacher, all right? Or it could be coming from the environment where they are, where they joined. So there are several factors that can be considered. However, still the goal of the teacher, right, is to make his or her students understand the lesson. If not, several problems will occur. All right, so now the students are left into a doubt whether, or rather the teachers are left into a doubt whether their students have learned something or not, or if they understand or not the lesson. So there are many different ways on how to measure the level of understanding of the students. But in my side, I tried to integrate technology, particularly artificial intelligence and data analytics to my craft, to my teaching methods. So in this study, I created a model to determine the type of understanding of the students, the easiest and the fastest way, okay? Without the teacher and we're guessing, hey, did they understand my lesson or not, all right? So this tool is actually useful to aid the teachers in assessing if the students really understand or had gained a knowledge from the lesson. Okay, now there are several studies that are already being uh, launched, or there are some different technologies that are already being used, just like in China, where students are using wearable devices like this one that you're seeing. It is called brainwave monitoring headbands, and it will actually detect who are those students that are not paying attention. Okay, now connecting these facial expressions that I am talking about, that was formulated by Paul Ekman, okay, to the assessment of the level of understanding of the students. All right, there are two ways of communicating with other people. One is verbal and the other one is non-verbal. So next to words, facial expressions are actually the primary basis of information to determine an individual's feelings, of course. So if you smile, then you're happy. Okay, so as stated by Butt and Iqbal on their study, facial expression is a very significant tool in the teaching learning process and can make this process more effective and interesting. So based on my researches, okay, and I'm oriented with this artificial intelligence, why not integrate this AI thing that I've known so many years ago into something that will help my craft, my profession, which is teaching. Okay, so there are already several studies revealing that facial expressions can be a good tool to assess if the students really understand your lesson or not. All right, so moving to the facial expressions, there are 6 universal facial expressions, okay, of emotions, and these are anger, disgust, fear, happiness, sadness, and surprise. Okay, now connection of, again, there's a connection between your emotions and how you understand something. Okay, according to the study by Liu in 2017, cognitive activities or learning process of the students are affected by their emotions. So if the students are feeling happy, that could mean they are learning more. If there are teachers here, you can actually it's really obvious. That's the term. It's really obvious that if the students are learning more, they're happy, they're more expressive. If they're not learning, they fear, they doubt, and most of the times becomes angry. So positive emotion can promote cognitive activities as also, while negative emotions can hinder them. All right. So what I did is these 6 universally accepted emotions of our face, I just grouped them into 2. Okay, so one is the negative emotions, and then the other one are the positive emotions. So there are 4 under the negative: fear, anger, disgust, and sadness. While under positive, there are 2 only: happiness and surprise. Okay, so this is the method that I have used actually to create the model. All right, so model is a different thing. This is the method. All right, so I started with the phase to be inputted, okay, or to be fed in the computer. Next is the machine, all right, the algorithm will detect if there's a phase. Okay, if there's a phase, then it will be classified according to the 6 universal emotions, and it will be clustered either positive or a negative emotion. Now, conveying all of this, we created a model which is based on a convolutional neural network. Now, let me go further deeper on the phase detection. So as I've mentioned or shown in this photo, the classifier or the algorithm that was used for detecting the phase is the HAR cascade. This is a popular algorithm to detect phase. So it first detects the features of the face, which could be the eyes, the eyebrows, and the lips, nose, and then block it, right? Once it detects the face, okay, the next step is to classify the emotions. Now, this is where our model comes in. So the model that we've created is actually trained, all right? How did I able to train that data? All right, so, or the model. So the model was trained, okay, by making it read the data inside the data set called FIR 2013 or the Face Emotion Recognition 2013. This data set is also available in Kaggle.com. So let me just describe to you the nature of the data set. So approximately there are 35,886 rows here. That would mean this is the number of photos inside. And each photo has 3 classifications or description. One is the category of emotion, okay? And then the second is the pixels, okay, which is the numerical interpretation of the photo itself or the emotions itself. And then these photos are categorized as per use, whether it's going to be used for training or for testing. Okay, so a total of 20,709 photos are used for training, and then 3,589 photos for testing. Okay, now let's go on to the deepest part of this research study, which is building the model in convolutional neural network. All right, so this model was based on sequential manner. All right, and then there are 3 layers of convolutional neural network that were created, made of Conv 2D, max pooling, and dense. If you're familiar with the uh, the code itself, so you're gonna call this actual methods there. All right, and then I've also used some activation functions like the ReLU, all right, which is rectified linear unit. So how does it work? This ReLU is actually something that is being triggered whenever it sees something. All right. So say for example, it sees a pixel 52. So it will be activated that 52 is actually a surprise type of emotion. And then along with that, okay, because this model is to be trained, right, there were 30 epochs, which means I run the reading or training of the data 30 times. Okay, so which means 35 times the photo, there are 35 photos, 35,000 photos, and these photos will be read 30 times. So after finishing, after reading the 35,000 photos, it will then go back. So this is where the model learns. Okay, so now as it learns the content of this data, okay, it achieved at the latter part from an initial accuracy of 45% only, okay, during the 5 to 10 epochs, it reached a maximum of 65% accuracy. For me, it's not yet a good accuracy level, all right? So 65% would mean if there are 100 photos, okay, that would mean 45 photos there are, or 35 photos there are is wrongly or interpreted incorrectly. All right, so this is the formula for getting the accuracy. Okay, now let's go on to the scenario. How did I come up? So after creating the model, I now launch it in a real test, right? So, but there are some limitations that I have set. So facial emotion recognition is much easier to be tested in a controlled environment compared to uncontrolled one. So I'm a teacher. I know that what is happening in the classroom is really an uncontrolled one. So students tend to do a lot of different things. Now, to reduce the underlying issues in real time, okay, the photos of the students were just taken, or I just took a photo of the students and then fed that to the computer for reading. Okay, although I've tried that, okay, in real time. However, the emotion recognition is so fast, so the computer is having a hard time, or the algorithm is having a hard time to analyze the photo constantly. Okay, so in order to determine the effectiveness of the model, just like what I've said, I ran a real test scenario on this. The experiment was naturally taken in a classroom while the lesson is currently conducted. So considering that the discussion is executed in a typical classroom setup and the students are just in grade 10, it cannot be avoided that some pose of the students is quite inappropriate and improper. And to address this problem, what I did was to place a camera position in front, okay, balancing the left and right side to capture the best angle of the students' faces. Okay, so real testing scenario. So the topic was discussed for 15 minutes with simple and brief explanations. So right after the teacher or I explained everything, a question is asked if the lesson is clear. Then a photo of the whole class was taken while they are answering this question. So this unexpected moment will definitely generate a very genuine reaction from the students. Okay, so there are a total of 10 student faces captured by the camera and were labeled as students 1 to 10. Okay, so in this case, this image is the one that interprets how the model analyzed the facial expressions of the students. So as you can see on our x-axis, students labeled as 1 to 10, and on the y-axis you have the 0 and 1. So 1 means understand and then 0 means did not understand. So in this case, the model analyzed that there are how many? 4 students who understand and that there are 6 students who did not understand. Okay, next. Because I'm not yet satisfied with how it works, all right, although I've known that the model can only predict correct facial emotions up to 65% only, I still I am not yet convinced on that. So I tried my best to compare the results with human intervention. So I've invited one of my friends who's working in the same industry for roughly 20 years, and she classified the same photo. All right. So obviously there are different readings between these two, the human versus machine, but I cannot actually compare if which one is better or not. Okay. Of course, humans are also prone to errors. All right. So in conclusion, so this study applies facial emotion detection to identify if the students understood a particular topic. So the test subjects are all male grade 10 students, and the topic being discussed is robotics. Robotics is a very interesting topic, but there's still other students, of course, who will not be able to understand that. So a normal discussion was conducted. Afterwards, the teacher asked the students if they understand the topic or not. Then I captured the photo of the students. Okay. So before that real test scenario, I already created a model which has only of up to 65% accuracy. Okay. So moving on. What are the different recommendations, or what are the different things that we need to apply to the study so that it can improve? So due to the condition that the test subjects are all male, I've this is a good output from the research actually. So why not create another data set? Okay, where all where the photos were taken from male only. Okay, so as per studies or as per my research, the facial expressions of female are more pronounced or more expressive than male. So there might be some um, uh, possible errors there. So then the accuracy level of the model can be also increased by either adding more layers of CNN, okay, and use other functions to normalize the data set before fitting it into the model. So when I say normalize, I can actually remove, okay, the neutral pictures or photos in the data set, okay, so that I have lesser options for the model to choose from, whether it's anger or disgust from the 6 emotions. Okay. And then further studies, okay, that I can recommend. Actually, I can recommend it to myself. Okay. Because I've already started this study of comparing how the human and the machine are analyzing the facial emotions. I can actually, or it is recommended that statistical analysis be applied on the human versus the machine interpretation and test the model to a different grade level or university level students. And of course, test the model to an online class. That will be my further studies. Okay, and thank you everyone. So that's all for my presentation. So you can reach me in this email address, raiza.borreo@nbtc.edu.ph, and watch out for my researches that I'll be publishing in scholar.google.com.
Wow, thank you so much, Dr. Raiza. That is very interesting. Wow, and
Thank you, sir.
there definitely are applications to this because definitely the way our students react to the way we teach them is of great value.
And
Okay,
that
I
I
personally
just
have a
want to add
question.
more things, sir. I just
Oh
want to
yeah, go ahead,
add
go
more things.
ahead.
I was really inspired to conduct this research because, as I've learned, the students must learn the lesson in the first 15 minutes of your discussion. So, putting this kind of technology beside the teacher and it's gonna give the hints to the lecturer, am I doing it right or wrong? So it's gonna help and make the discussion more progressive and fruitful.
Okay. I personally have a question, Dr. Raiza,
Okay,
here.
sir. Yes.
This was done with a group of 10 students.
Actually, there are 25 students, but only 10 was captured. So um,
Okay.
another recommendation is to use a wider lens camera.
Mm-hmm.
Yes. So there are many rooms for improvement for this study, actually. Yes, sir.
Sure, sure. And have you considered instead of just taking like a snippet, a photograph snippet,
Yes, sir. Yes, sir.
you consider take like like a video so you would see the transitions
Oh,
of the
that part,
emotions?
sir. That part, sir, I did not because if I tell the students that I'm actually doing a research, they will act properly. So
Okay.
yeah, yeah, that's what I am considering. Or maybe in the future I can uh, place a CCTV. Something that they don't know that they are being monitored. Something, but I need to ask permission.
Definitely. And probably permission for ethics sake as
Yes, yes, sir.
okay, we have one question, Dr. Raiza. So this particular attendees thought that your presentation was great, okay? And the attendee wants to know, how did you segregate the faces since you took a group photo?
Yes, sir. Okay. Actually, it's automatic. With the R cascade, okay, that is used for classifying images, it's automatic that it's gonna capture the photos. There's no such thing as segregation. Automatically, if it detects face, then all at once these photos will be evaluated.
Ah, I see. So the application takes a look at everything
Yes,
holistically
sir.
as a whole picture.
Yes, sir. Yes.
Wonderful, wonderful. Okay. I do not see any further questions either at the
They can
Q&A or
email
the
me,
chat
sir, or
box.
they can visit me here.
Definitely. So, folks, if you are very interested to know more about this
Yes,
particular
if you are
study,
interested, I'm gonna promote also, sir, if you are interested with this study, it's my pleasure to, accept your contributions, your ideas on this. There's a lot of ideas that is running into my mind. I want to consider the pose, the elimination, and all the external factors that affects how face is being detected by the computer. So things like that I cannot do alone, so I need some team, or if we can collaborate, that's
wonderful.
better.
So
Yes,
there you go, folks, an open invitation for everyone. Okay. Contact her, Dr. Raiza. So thank you so much, Dr.
you're
Borreo.
welcome, sir, and thank you also for inviting
Looking
me here.
forward.
It's my pleasure, sir.
Wonderful. Thank you so much. So, ladies and gentlemen, that was Dr. Raiza Borreo. Thank you. Wow. So definitely, the level of engagement can be detected, and that's an exciting field to take a look at. So we are now into our 12 p.m. slot, and our next speaker brings with her